Welcome back to Foundry Ops. In Module 1, we established our mission and built our strategic foundation for our project, our forward operating base. We didn't just create folders, we created a blueprint for a scalable, governable, and trustworthy system. But a base is useless without intelligence. An operations platform is worthless without data. In this module, we get our hands dirty. We're going to establish our first communications links and bring the raw intel feeds for the Outer Heaven hub into the platform. And we're going to do it with the mindset of a strategist. We won't just dump the data in, we'll verify its structure, we'll understand its origin, and we'll set up the automated tripwires that form the bedrock of a reliable system. The goal isn't just to get data in, it's to begin the process of building trust in the data from the very first step. We'll begin in our raw data folder, as we established. This right here is our digital evidence locker. The data that lands here is the original, untouched source material. We never modify anything in this folder. We only read from it. So, it's empty right now, and to bring our data in, we'll use this little plus menu, and we will select Upload Files. Now, for this training exercise, we're going to use this option to bring in some CSVs from our local machine. But just a quick important, philosophical aside. In a real-world production environment, an engineer would almost never do this. Manually uploading files is not scalable. It's prone to human error, and it creates a weak link in your governance and audit trail. The proper engineering approach is usually something more along the lines of using a data connection to build a live, automated, and scheduled sync, whether that's a database, an API, or a cloud data store that ensures the data is always fresh and the process is repeatable and auditable. But for today, this upload will serve to get our raw intel into the system so we can begin our work. We're bringing in our initial feeds, the operative roster, leave emissions log, equipment catalogs, and so on, affiliation list, and a couple other things. So let's bring them in. Our initial feeds are in the base, and the first thing a good engineer does is establish a clean, professional workspace. So you see the file names are a little bit messy, and we should probably clean it up before we do anything else. And we'll start with the operative roster. We'll just call it operative roster raw. We'll do the same for the rest of our files. And notice I will be naming the two equipment catalogs 1 and 2 to keep them distinct. And this simple step is just data hygiene, and it's important to keep everything organized. Now let's do a quick threat assessment of our new intel. We have our operative roster raw folder, which is our people, the mission logs, which is our operations, 2 equipment catalog files, which suggests data is coming from 2 different systems, or maybe you had one older version and one newer version. And these may need to be combined later. We also have the operative loadout file, which links people to gear, and finally the affiliation list, which tracks the enemy forces we're up against. Now, for the most important mindset shift for a data strategist, when you receive a raw data dump like this, you must assume it is all compromised. You trust nothing. Every file is likely plagued with its own unique set of structural problems and content errors. To prove this hypothesis, let's perform some deep recon on our 2 most critical intel files, the roster and the logs. The problems we find here will be representative of the issues across the entire project. So let's start with the operative roster. Look at that. I don't know what this untitled column is. looks like this column is also a name and looks like a mess. So this immediately confirms our hypothesis. The system is compromised. So Foundry failed to correctly interpret the first row of our file as the header. And this is a critical structural failure, but we don't panic. We just find a solution. It's really simple. We can correct this directly using the Edit Schema tool. This gives us manual control over the dataset structure. The fix is simple. We're telling Foundry to promote the first row of data to be the column headers. The preview instantly updates, showing now the correct names. So we'll save and validate this change, permanently fixing the structure of our raw data set. And with the structure repaired, we can now inspect the content. A quick scan reveals exactly the kind of quality issues we expected. For example, the status column has inconsistent values, like active and the number 1. And there's some null values. I see that MIA is written in different ways. And the skills column is a messy, multi-valued text field, which is more or less unusable for filtering. Now, if we're to go back, and let's just check our missions logs, we're going to find more or less that the story is the same. So this file is the record of our operations, but a quick inspection of the location data, so the target latitude and target longitude, you will find a critical flaw. We have like non-numeric text like 100 east, where a coordinate should instead be. So this data would break any attempt to map our mission locations. So we've proven, once again, the hypothesis that our raw intel is full of errors. We've identified some key targets for our cleaning operation, which will launch in the next module. The next step would more or less be to build a trustworthy system. It's not enough to know what the data says, we also have to know its origin. Because later on, when we're going to make adjustments, we want to know the chain of edits. So we have to know the origin of data, where did it come from, how was it produced, and so on. And to answer this, we'll use one of Foundry's powerful governance tools. So let's go back to our operative roster. And in the All Actions menu, we can find a tool called Lineage. So let's open it up. And this right here is the lineage graph. Think of it as a family tree for your data. Right now it's very simple. It's just a single data set. And over here you'd be able to more or less find out information like the type of data set. And we can tell that this is a direct upload, and it's the beginning of our story. And as we move into Module 3 and start building pipelines to clean and combine our data, this graph will grow. As mentioned, we'll more or less show every single transformation, every join, every parent and child. And if a commander ever asks how was his decision made, or an auditor asks, show me the full history of this data, this graph is your answer. It's the unbreakable audit trail that underpins the entire system. And with our data's origin confirmed, we're ready for the final step of our acquisition process, which is setting up our automated security systems. So we've manually confirmed our intel is flawed, but a strategist never relies on manual checks for critical systems. To build a resilient and trustworthy system, we must encode our standards into the platform itself. We need an automated, persistent security system for our data. And for this, we can use the data health application. And the philosophy here is simple. We're about to build our first automated gatekeeper. This check will stand guard over this dataset and inspect every future update forever. We'll start with a content check, teaching the platform our official definition of what a valid status is for an operative. We'll apply this rule to our messy status column, and we want to provide the gold standard of allowed values and explicitly forbid any empty values. So for a field, this is critical. An unknown status is a risk we cannot accept. So we should check this off. Now, here's where we move from just detecting a problem to creating an operational process around it. It's not enough for a smoke detector to beep. It needs to call the fire department. And we'll configure this to automatically create a trackable issue on failure and assign it to key personnel. So myself and Muzamil, he's the Autocon for our operations, our lead data engineer. And this will create an automated accountability loop. What happened? There. Okay. And yeah, the tripwire is more or less now set. So let's save this. All right, so just resuming the video. This check usually refreshes each time the dataset updates. So I just sort of imported the same file to do a quick update. So nothing has changed in terms of the data, but there it is. The check has failed and our automated system works. Foundry has detected the problem and has assigned a task to the right people to fix it. And more or less, every time you will be working with this data in the pipeline builder and changes are made to the data, the health check will always inform you if, in this case, the specific column, the status column, has the allowed column values or values that is not allowed, meaning it's an unhealthy column. You should check something. And this brings up a critical strategic question. Do we need a health check on every single column in every file? And the answer is no. That's overkill and it creates unnecessary noise. You apply health checks like a sniper, not a machine gun. You target the columns where bad data would have the most catastrophic consequences. So you have to think about your join keys, your critical timestamps, and the specific fields that your end users will be filtering on in their applications. Those are your high-value targets for data health checks. And for this course, we're only setting up that one check because it's a good example. But in a real-world system, I would add checks for things like operative ID to ensure it's never empty. And for our date columns as well to ensure that they are always in a valid format. The most important takeaway is this. The health check is now a permanent living part of our data foundation. Every single time, as mentioned, the change happens. So let's say even a new operative roster arrives, the check will run. So this failure is the justification for everything we will do in Module 3. We don't clean data just for the sake of it. We build data pipelines to solve specific known problems. And this has given us the problem definition. By this, I mean the health check. It has found the enemy, and in the next module, we will engineer the weapon to fix it. So let's reflect on what we've really accomplished. We didn't just upload data, we treated our raw intel with professional skepticism. We interrogated its structure, we audited its origin, and we established an automatic sentry to stand guard over its quality forever. That failing health check on our screen isn't a problem, it's clarity. It's the actionable intelligence that gives us our next mission. It proves that the data we are being supplied is not fit for operational use, and it gives us the justification to build the tools to fix it. So this is the fundamental mindset. You don't just accept data, you validate it. Build a foundation you can trust, because everything else, every analysis, every application, and every decision depends on it. Our raw intel is now contained and monitored, but it's not yet an asset. In our next module, we'll take on that open issue. We'll enter the data processing unit, fire up the pipeline builder, and begin the real engineering work. forging our raw material into a trusted integrated core of the Outer Heaven Intelligence Hub. So your mission, should you choose to accept it, continues there. Dismissed.